Good morning, everybody. It's Miss Springer. Today is Tuesday, September 23rd. Sorry, I was looking at my calendar. And we're going to go ahead and get started with class today. So our do now for today, we're just going to practice two problems. One of them is using the distributive property, and then one of them is a variables on both sides problem. So directions, please complete the following problems. Get out your notebooks, pencils, and calculators. So go ahead and get those out. All right, for this first problem, we've got 5 parentheses 2y minus 9 end parentheses equals 17. So remember, oops, didn't mean to do that. Remember when you guys were in the 5th and 6th grade, probably 5th or 4th actually, you guys learned about order of operations. So if you have parentheses, PEMDAS, parentheses comes first, so we've got to get rid of these parentheses. We've talked about this before, but if you remember from back in the 5th grade, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. We've got to get rid of these parentheses first. Before we can start moving anything around, before we can start attempting to solve for y, we've got to get rid of these parentheses. So I'm going to go ahead and explain the distributive property again for those of you who might have missed our previous lessons. The distributive property means we've got a number directly in front of parentheses. So this could be one term like 5 parentheses 2y, 5 parentheses 2y minus 9, or we could have as many terms in those parentheses as we're given. This being said, that number in the front, so in this case it's 5, that number in the front of the parentheses is being multiplied to the terms within. So what that means is this 5 is being multiplied by 2y and negative 9. That's how we're going to get rid of these parentheses and simplify that left side of the equation. So we're going to do 5 times 2y. Well, 5 times 2 is 10. I'm going to tack on that y at the end. 5 times negative 9. So make sure you practice entering those negative numbers because I don't want you guys to make any silly mistakes just because those negative signs confused you. So 5 times negative 9 gives me negative 45. And then I'm going to go ahead and look at my right side. Is there anything to simplify? There is not. So we're in luck. This is actually just an easy 2-step equation. So I'm going to go ahead and highlight my variable terms. I'm going to highlight my constants. And remember, I need to get all of my variables on one side, all of my constants on the other side of the equal sign so I can start solving for y. That being said, all of our variable terms are actually already on the left side. So we've got 10y all by itself, but we have that negative 45 attached to it. So to get rid of that or to move that 45, we're going to go ahead and add, oops, 45, that was sloppy, sorry. We're going to add 45 to both sides, because the opposite of a negative 45 is a positive 45. I'm going to go ahead and bring down my 10y. And then I've got 17 plus 45. So 17 plus 45 equals 62. All right, and finally, I'm going to go ahead and get my variable by itself, and we're able to do that because we've got all of our variable terms on one side, all of our constants on the other side. So 10y equals 62. To get y by itself, I'm going to go ahead and divide both sides by 10, and that's to undo that multiplication between the 10 and the y. Opposite of multiplication is division, so we're dividing both sides by 10. 10y divided by 10 just gives me y. And then 62 divided by 10 is going to give me 6.2. All right. If there's no questions on that one, we're going to go ahead and move on to the second warm-up problem. So over here, we've got 2x minus 3 equals negative x plus 12. So we're going to start this by identifying our constants and our variable terms. Remember, our constants are terms without a variable. Our variable terms are the terms with the letter or the variable. I'm going to go ahead and take my pen and draw my line down the equal sign so I can remember to do all my steps. And then now we've got to this point, I'm looking at both sides. There's nothing I can simplify. There's no parentheses. There's no combining of like terms. We've just got a variable term and a constant term on both sides of the equal sign. So once we get here, we're able to evaluate and start moving stuff around our equal sign. So I'm going to look at 2x and negative x. So I'm comparing my variable terms. I'm thinking to myself, which one is smaller, 2x or negative x? Negative x is smaller because negative x is the same thing as, oh gosh, what area there? Sorry, guys. Negative x is the same thing as negative 1x, and negative 1 is smaller than 2. So to move a negative x to the left side of the equal sign, we're just going to go ahead and add, that's an addition sign. We're going to add x to both sides. So 2x plus x is going to give me 3x, because remember that's a 1x. I'm going to bring down negative 3, and then I'm going to bring down 12. I don't want you guys to think that that's a negative or anything, so I'm going to erase that. There we go. All right. Next, I'm looking at this and I'm seeing I've got a variable term and then I've got two constants, negative 3 and 12. Remember, I need to get all my constants to the same side of the equal sign. So I can do that by moving that negative 3. And I can move a negative term by adding it to both sides. So I'm going to add 3 to both sides. I'm going to bring down the variable term. So I've got 3x equals 12 plus 3 gives me 15. And then to get x by itself, we're going to go ahead and divide both sides by 3. 3x divided by 3 is x. 15 divided by 3 is 5. All right, so we've got all of our terms by themselves. X equals 5. All right, so I wanted to review these skills because today we're actually going to be doing something I think is fun, but I'm also a math teacher, so my definition of fun is a little different than yours probably. So we're going to go ahead and use the math that we've been learning for the past couple weeks, and we're going to talk about using it in real world scenarios, which makes me so excited because, again, we're trying to make you guys, we're problem solvers, math users, so you're able to solve problems in your real lives, apply this math to your adult life. So when you leave Princeton, you're self-sufficient and you're going to be successful. So when am I ever going to use this? I hear this every now and again from a student, but you're probably all thinking it, like when I'm making you do multi-step equations, you're probably like, when are we ever going to use this? So I wanted to give you a couple of examples. So budgeting, I'm sure this is something all of your parents do. It's something I do. So budgeting, it's where you take your income, so how much money you make, and you kind of think about all of your bills like electricity, gas, insurance, your car, your groceries, and you can use algebra or equations to make predictions about that type of thing, or you can use it for budgeting in the future. So you can use it that way. You can use algebra for rates, and what I mean by rates is like how much you make per hour. You can make predictions. So if you were doing like a bake sale or something, you could write an equation, and we'll go over some examples later this week, make predictions on how much money you're going to make at a bake sale or a lemonade stand or something like that. So you can use algebra to make predictions, use it for budgeting. You can use it for all sorts of scenarios to predict things. So I wanted to show you guys this, since you guys are my remote class. This is something that's hanging up in our classroom. So this is a list of key math words. So I've got addition, subtraction, multiplication, and division. These are all very helpful. I would suggest making a note of them in your room at some point as well. So basically what these are is when you see these words in word problems or real life scenarios, these are typically the operations that the words are indicating. So when you hear things like altogether they have, that's typically addition. When you're thinking you're going to reduce your, or you're going to decrease your number by so and so and so, that's subtraction because you're taking away. Multiplication to double, triple, that's typically when you're multiplying by 2, by 3. And then division, shared equally, separated, equal parts, that kind of thing, how many in each, those are all indications of division. So we're going to kind of be looking at these words. We're going to be, and there's a bunch that aren't on this list. I just tried to put together some of the common ones for you guys. So we're going to see some of these in the word problems that we're going to read. All right. So I'm going to read this one with you guys real quick. So it says, Miss Sprunger took a taxi home from the airport. So I don't know if you guys have ever been to the airport. I live kind of far from the airport. It's in Kentucky, for those of you who don't know. The taxi fare was $2.10 per mile. And she gave the driver a tip of $5. She paid a total of $49. How far did she travel? So I want you guys to think of, what do we know? Well, we know that the taxi fare, so when it says taxi fare, that means they're charging us $2.10 per mile we travel. So we know that. We know that I gave the driver a tip of $5. So typically when you're going out to eat, or you're taking a cab, or you're taking a taxi, anything like that, you tip people. So that's a one-time payment of a certain amount. Like at a restaurant, you give a $5 tip to your waitress, that kind of thing. She paid a total of $49. So I see the word total of $49. So what do we know? We're taking notes here. What do we know? We know that our taxi fare is $2.10 per mile. We know, I'm going to take it off of, I want a pen, not the calligraphy pen. There we go. We know that I gave the driver a one-time tip of $5. So I know that $5 is a number that I have. So that's right there. And then she paid a total of $49. So I paid $49 for the whole thing. So then I'm going to look at the second question. What do we need to know? So what are we solving for? What are we trying to figure out? How far did she travel? So what do we need to know? How far I traveled. All right. So this last question says, what does our answer mean? We're going to wait to solve that. But I want to explain this equation that I wrote, because for the first couple ones, we're going to have the equations given to us. I'm going to explain what they mean within a context. So this is 210m. So if I'm looking at this, I'm going to take my highlighter. 210m. That's this part right here, 210 per mile. When we see the word per, I know that right here it's under division, but I really need to add it over to the multiplication, because per can mean multiplication or division, which is kind of the tricky part. But if we're thinking for every mile, so we're going to multiply 210 times however many miles I traveled. She gave the driver a tip of $5. Sorry, it's supposed to be blue. So I gave the driver a tip of $5. That's our constant. Notice there's no variable with that. There's just, it's just $5. It's just by itself, because we're not multiplying it by anything. And then she paid a total of $49. So I paid a total of $49. So when you see that word total, that means the equal sign. So that means equals, and then the next thing. So we've got this two-step equation to solve. So I've got 210m plus 5 equals 49. I'm going to go ahead and work on solving this. So I've got my variable term here, and I've got my constants right here. Remember, I want to go ahead and move all of my constants to one side of the equal sign. So I'm going to go ahead and subtract 5 from both sides. And we've done this plenty of times when practicing two-step equation. Sorry, yes, this is a two-step equation. So plus 5 minus 5 cancels. I'm going to go ahead and bring down my $2.10 times m. And then 49 minus 5, it's going to give me 44. All right, now I'm going to go ahead and solve for my missing variable. I've got all my variable terms on the left. I've got all my constants on the right. I can go ahead and make sure you pick up your calculator for this. I've got 44 divided by $2.10, so 210. And that's m equals, and it's 20.95. So 20.95 is m. So when you see this, what does our answer mean? So typically when we solve, variable equation solving, multi-step equations, anything, we typically just get a letter equals this number, okay, move on. But when we're actually using this in our real lives, we want to think about what does our answer mean in this context. So M means something, we solved for something. So what do we need to know? How far I traveled. What does our answer mean? How far I traveled. So our answer means we traveled 20.95 miles. So our answer means we traveled, I think I spelled traveled wrong. Oops. I'm not gonna erase it. We traveled 20.95 miles. All right. So I want you guys to start thinking about what does this number mean in this context? What is this, what are we supposed to be doing here? So this is kind of our starter problem. I'm going to try and be a little more neat and nice in the next one. All right, we've got this one. So this says Adam bought 10 hats. A week later, half of all of his hats were lost during a move. I don't know if any of you guys have ever moved before, but it's chaotic. I moved in August and I'm still finding stuff and I still have stuff missing. So he lost all of his hats during a move. There are now only 16 hats left. With how many hats did he start? So we're gonna look at this first part. What do we know? We know that he bought 10 hats. So bought, when I think bought, that means plus 10. So he bought 10 hats. So that's plus. That's not losing 10 hats. That's plus 10 hats. A week later, half of all of his hats were lost during a move. All right. So a week later, half of all of his hats were lost during a move. So however many hats that he had, he now only has half of them. So we need to keep that in mind. So half lost. We lost half of the hats. There are now only 16 hats left. So if I'm thinking about my words, let's see if there's anything. Any words that we have in here. So there are now only 16 hats left. So only 16 hats left. That makes me think that we're going to have equals 16. So we're going to be figuring out what happened to those hats, and then we're going to figure out how many he started with. So what do we need to know? It says with how many did he start? So we're going to go ahead and say how many hats did he start with? All right. All right, so we're gonna answer what does our answer mean once we solve. So I wrote this out for you guys. So remember, I know a week, so let's see, let me get my highlighter out. So Adam bought 10 hats. Bought 10 hats, when I think bought, I think plus 10. A week later, half of all of his hats were lost. So half of his hats were lost during a move. And you remember, we're trying to figure out with how many hats he started with. So I'm taking how many hats he started with and I'm dividing it by 2 because that's taking 1/2. All right. Now there are only 16 hats left. So only 16 hats left equals 16. How many did he start with? All right, so we're going to go ahead and solve this problem. So I've got our variable term in blue, and then we've got our 16 and our 10 are our constants. So remember, we want to start with x, or we want to save our variable term for last. So I'm going to go ahead and subtract 10 from both sides. And the reason I'm doing that is because I want to get this variable term, whatever's going on over here, I want to get that by itself so I can eventually solve for x. So we're going to subtract 10 from both sides because the opposite of plus 10 is to subtract 10. So 16 minus 10 is going to give me 6. And then I'm going to go ahead and bring down x divided by 2. And I'm actually going to write it like this because that's kind of how we see it typically. All right. Now we've got x divided by 2 equals 6. We want to solve for x. So we want to get x by itself. Well, right now, x is being divided by 2. So what is the opposite of division? Multiplication. So I'm going to go ahead and multiply both sides by 2 so I can get rid of that division. So divided by 2 times 2 cancels. I'm going to be left with x equals 2 times 6, which gives me 12. So what does our answer mean? So with how many hats did he start? He started with 12 hats. And let's read this again. Let's see if it makes sense. Adam, so if he started with 12 hats and then he bought 10 hats, okay, that's going to be 22 hats. A week later, half of his hats were lost during a move. There are now only 16 hats left. With how many did he start? So what does our answer mean? How many did he start with? And I know these kind of look the same, but he started with 12. So that's, how many did he start with? 12. All right, this next one. 47 students went to the symphony with their parents. The rest rode on 7 buses. I don't know if you guys have ever been to the symphony before. It's amazing. The Cincinnati Symphony, the CSO, Cincinnati Symphony Orchestra is fantastic. They also have a children's one, which is also amazing. It's just all fantastic. The rest rode on 7 buses. If a total of 297 students went to the symphony, how many rode on each bus? So we need to think of a couple of things here. What do we know? All right, so they went on a field trip. 45 students went to the symphony with their parents. So what do we know? 45 went with their parents. The rest rode on 7 buses. So there's 7 buses. And a total, so I see that word total, of 297 students went to the symphony. How many rode on each bus? So these are some of the things we know. We know that 45 students went with parents. There were 7 buses, and there were a total of 297 students who went to the symphony. So we want to figure out, what do we need to know? How many rode on each bus? So that's what we're trying to solve for. That's what our variable is going to represent. So what does our answer mean? We're going to solve that after. So notice that there's no equation here. So we're going to practice writing an equation really fast. So if we know that there are 7 buses, so what I'm going to do is I'm going to write 7b, because I know that the remaining amount of students, they're going to be on those 7 buses. So I'm going to make sure that I know there's 45 students that went with their parents. So 45 students went with their parents, and then a total of 297 students went on the field trip. So let me get my highlighter out really fast just to recap. So there were 7 buses. 7 buses. There were 45 students who went to the symphony with their parents. So there were 7 buses, and we're trying to figure out how many students rode on each bus. There were 45 students who did not ride on a bus. So 7b, so 7 times the number of students who rode on each bus, plus that 45 who went to the symphony, gives us a total of 297 students who went to the symphony. So we're going to solve this 2-step equation really quick. So let me go ahead. Get this out. Remember, we want to save our variable term for last. So we got 7b plus 45 equals 297. I'm going to go ahead and subtract 45 from both sides. And I'm doing that because I want to save my 7b for last. That's going to cancel. I'm going to bring down my 7b. 297 minus 45. Go ahead and enter that in on your calculators. You should get 252. All right, we've got 7b equals 252. So when we divide both sides by 7, so we've got 7 buses worth of students gives us 252. Remember, we took away those students who rode with their parents, so now we're solving for how many students were on each bus. So I'm going to go ahead and divide both sides by 7. 7b divided by 7 gives me b. 252 divided by 7 gives me 36. All right, so if I'm looking at this, what does our answer mean? What does this b represent? B represents how many students rode on each bus. So how many students rode on each bus? 36 students. Okay. So this is going to be the last problem we go over for today. I'm going to go ahead and end today's lesson. If you have any questions, make sure you're emailing me, letting me know if you need help with anything. I'm going to go ahead and try and come up with some more word problems that are a little bit more relatable to you guys, but I'm going to go ahead and I will see you all tomorrow for class. Have a great day, and I'll see you on Wednesday. Bye.